So, hello everyone. This is Tarun. Okay. So, I'll be handling your advanced placement calculus part. Okay. So, first thing on discuss like what is this AP calculus. Okay. So, this is set of two distinct advanced placement calculus courses, which is your AP calculus AB and the AP calculus BC. Okay. So exams offered by the Americans, which is non-profit organization College Board, and AP Calculus AB covers the most basics, introductions to limits, derivatives, and integrals. Okay, and AP Calculus BC covers all your AP Calculus AB topics plus additional topics, which includes more advanced integration techniques such as integration by parts, Taylor series, parametric equations, vector calculus, polar coordinates, functions, curve, and interpolations, etc. Okay, so here we welcomes you again. Okay, so this is a US based tech company, okay, which is Gyan Marga Technology, and we are having a site apexam.us. Okay, so you can get uh, links there. Okay, you will be using this app AP Calculus, which is available on Google Play Store also. Okay, so as we have discussed, you can download it from apexam.us also. Okay, so please visit there. Okay, now next thing, this app effectively app that helps you to learn within context resources or live lectures will be ready for this challenging exam. Okay, so in the app we have introduced slides, textbook, videos, and questions also. Okay, so like you can practice your questions and give your exams. Okay, so both type of questions are included as well as your MCQ and then the free response type questions. Now let's discuss about the first AB program. Okay, so as you know, this AP Calculus AB is an we call advanced placement calculus course. So it is traditionally taken after the pre-calculus, and it is the first calculus course offered at the most schools, except for possibly a regular calculus class. The pre-advanced placement pathway for the maths help prepare students for further this advanced placement classes and the exams. Right now, what is the purpose of this course is, okay, so and this AP course in calculus consists of a full high school academic year of work that is comparable to your calculus courses in colleges and universities. So it is expected that the students who take an AP course in calculus will seek to college credits, college placements, or both from the institution of higher learning. The AP program includes specifications for two calculus course and the exams for each course. The two course and the two corresponding exams are designed at the calculus AB and the calculus BC, as you know. Okay, so calculus AB is offered by school that can organize a curriculum for the students with the advanced mathematical ability. Okay, so let's discuss few things about the AB program first. Okay, so as you know, this course is based on integral and the differential calculus. Okay, so it is an introductory course for 1 year. Okay, so the topics which are covered in the AB program, the topics which are covered in the AB programs are: first is your limits and the continuity. Second one is your differentiation, which is includes your definitions and the fundamental properties of the differentiation. Third one is your differentiation again, which is a higher level of differentiation like composite, implicit, and inverse function. Okay. Fourth is the application of differentiation. Fifth is analytical application of differentiation. Sixth will study integration and the accumulation of change. Seventh, we're gonna study differential equations. Eighth is your applications of integration. Right now, the prerequisite of this course is first, before studying calculus, all students should complete all the equivalent of 4 years of secondary maths designed for the college-bound student, in which they study algebra, geometry, trigonometry, analytical geometry, and the elementary function. Right. The second is you should have the prior knowledge of the properties of linear polynomials, rational trigonometry, ITF, and the piecewise. This we can call defined functions and know how to graph these functions and solve equations involving those. Okay, so now let's discuss few things about the exams related to the AB program. Okay, so the exam duration for the calculus AB is 3 hours and 15 minutes. Okay, so the exam is divided into two sections. The first is the 45 multiple choice question with the 1 hour and the 45 minutes. Okay, so there you can target your 50% of the score. Okay, part A, which is a graphing calculator, will be not permitted. Okay, which is 33% of the score. Okay, part B, calculator will be allowed. Okay, So that is 16.7% of your score. Okay, and section 2 is the your free response questions, okay, which will be having 6 questions of 1 hour and 30 minutes. Okay, that will be again of 50% of the score. So part A will be having 2 problem where calculator will be required, that is 16.7 of the your total score, and part B will be 4 problem which is graphing, calculator will be not allowed, which is 33.3 of the total score. Okay, so this was regarding your exam structure for the this first one. Okay, let's discuss the course for the BC program. Okay, so this is a course based on calculus and the subsequent single variable calculus. It is also an introductory course for the 1 year. Okay, so the topics which are covered are, the first is limits and continuity, second is your again differentiation with the fundamental properties. Okay, third one is your composite and implicit inverse function differentiation. Fourth one is your contextual applications of the differentiation. Fifth one we came to for the analytical applications of differentiation. Then the sixth is integration and the accumulation of change. Okay, next is your differential equations, seventh one. Eighth is your application of integration. Now the two new topics are introduced, which is parametric equations, polar coordinates and vector valued functions, and the last one is the infinite sequence and the series, okay, which were not included in the AB programs. Okay, now the prerequisites the same for the as AB program which we have discussed. Okay, like you should know all the basic maths, which is includes your higher algebras, functions like geometric, trigonometry, analytical geometry, okay, elementary functions, as well as polynomial, rational, trigonometric, inverse trigonometric functions. Okay, so all these things you must know. Okay, and solving know how to the graph those functions and solve equation involving them. Right, now let's discuss the exam structure for this. Okay, exam structure is also same. Okay, so this is same. Okay, so we don't have to discuss it again. Okay, this is same as the AB program. Okay, 50-50 will be divided, okay, for the MCQ and the free response questions, and again there will be two parts, part A and part B. In part A will be calculator will be not permitted, which is 33% in the MCQ part. In part B, which is 16 point of the 7 total of the score, where calculator will be allowed. Similarly for the this problems free response type, there will be 6 questions and will be covering like same. Now let's come to the next part. Okay, so as you know, you should have a basic knowledge of the functions and all this. Okay, how to plot the graphs and all. Okay, so a key requirements is to take the class in a 1 semester course, right? Okay, similarly we have introduced your AP physics, C mechanics on the same. Okay, so you can find out the all the details on the our site, which is apexams.us. Okay, the class parallel or prior taking to the same course. Okay, so for AP physics, a complete algebra second or the geometry will be required. Okay, so this is regarding your prerequisites and co-requisites and the requirements. Next, resources from college board. Okay, so you can practice the exams for, okay, so which is from the college board side. You can sign out and you will get all the details there. Okay, with this how they are updating. Okay, so this is the given site which is given here. Okay, so you can log in while make your account and log in it and just check out the site. Now using our program, which is Gyanmarga Technologies. Okay, so first you need to purchase the Gyanmarga program. Okay, then you have to study every week. We are conducting lecture every weekend. Okay, there will be, you can check your doubts and we'll be solving your doubts also. Okay, and we'll cover roughly 1 unit every 2 weeks. Okay, so this lecture series is integrated into the textbook. Okay, there will be preparatory requirements for students to pre-learn prior to the lecture. Okay, we'll be providing slides also. Now the tutorial series will be covered briefly the lecture and slides, but largely focused on the problem solving. Okay, so we'll be solving live problems in the class. We'll do both multiple choice and the free response questions. We'll assign post lecture problems every week to the help the students preparation, and also students are encouraged to also look at the advanced placement and the Khan Academy problems and the solutions to extend their conceptual readiness for the exams. Okay, so these things we can do. Next is what about the exams and when and how. Okay, test taking. So first is plan to take the 2 preparatory tests. Second is one in the mid-April and the one in the late April. If you are taking the test in May, right? So same We'll be having exams in either in the mid-April and the late April. Okay. Now the third one is we'll provide a test for the students to take, and the questions are already implemented in the app. You can check out. Fourth is we can grade your exams if you can scan and send it to us, so we can check out and what are the mistakes that will be handling you. Okay. Fifth one is they will suggest the techniques to improve scores also. Okay. So when you're gonna join live classes, we'll tell how to solve the problems, what are your mistakes. Okay. So all these things we're gonna discuss in the live lectures. So this is our site. Okay. So which is apexams.us. Okay, so visit our site for class links. Okay, so there will be updations regarding it. Okay, so this page you're gonna go there. Okay, so this is regarding our site. Okay, so let me go through it once again. Yeah. Let me check it here. Yeah. So these are the lectures timings, and you can check out all these things there only. Okay, so this is our site. Okay, which is apexams.us. Okay, so you can check out. New subjects will be adding here like pre-calculus also, APCS principles and all these things. Okay. So for calculus part, you need to visit there. Okay, so you can download your app and all these things. Okay, and you can just type your mail and sign up and join with us. Okay, so now let's come to this part again. So this was regarding our site. Okay, all the lecture timings, all these things we can check out there. So thank you again. Okay, so download app Calculus and do register and join with us. So now let's come to the first unit. Okay, so which is your limits, right? As you checked here, what are your first unit, limits and continuity. Okay, so in this unit you'll learn about the essential basics of calculus. Okay, so limits and continuity are the backgrounds for all of the AP calculus, so it's crucial to understand these concepts. This unit should be about 10 to 12% of the AP calculus AP exams, or 4 to 7% of the AP calculus PC exams, right? So this list will be a good place to start in terms of self-assessing on what you need to study or learn. Okay, so as you are looking throughout the list, while at the other topics you don't remember, still need to relearn. Once you identify the topics that you would like to more help on you, that you can go through the full study guide page. After it, you need to get some information from there, right? So now this is the first. Okay, so definition of limit is important to understand, as this definition will help us to understand derivatives in the later unit, right? So here we're written dy by dx, which is including your limits from h tends to 0. Okay, so functions f of x plus h minus of f of x divided by h. H is almost tends to 0. Okay, so this is regarding your limit first. So to read limit notation, we'll start to looking at the value along with the x-axis of the function fx, right? So once you reach the where value, you want to evaluate the limit by finding the y value of the function. Okay, you'll be finding the y value of the function. So that is limit x tends to a f of x, which is equals to your L limit, right? So now let me write this first, which is your delta y by delta x. Okay, or you can write it as y2 minus y1 divided by x2 minus of x1. Okay, so in AP calculus, limits can be used to represent a constant change in the function. Constant change in the function. Okay, so now the rate of change of a function is equals to the formulas, which is delta y by delta x. So that we can write it as y2 minus y1 divided by x2 minus of x1. While this formula may look scary to you, okay, so it's actually just the slope formula. So you may remember this arises over and the change. Okay, and change in the y over the change in the x. Okay, in short, yes, change can occur at an instant. As you get further along in the course, you'll learn about the derivatives. So derivatives depends on the limits, and the derivative is the rate of the change of the functions at that instant. Okay, so what we call this as instantaneous rate of change. Okay, we'll see example based on those later. Okay, so first thing, a limit. Now let's define the limits first. Okay, let's divide it finally. So a limit is the y value functions approaches as it approaches a certain x value also, right? So the notation for the limits will become limit x tends to a, f of x is equals to L. Okay, so now here fx is your function. This acts as you approaches a along the x axis, right? And this L, what is the y value? We're getting closer to that. Okay, when we are giving this a values to those functions, right? So this part you need to copy. You can write limit x tends to a, f of x is equals to L. Correct. Okay, so now let's look out at the graph, which is x plus 1. Okay, function is given, which is your x plus 1. So this means x approaches on the graph of the functions, the value on the y-axis at the function approaches is limit, right? So while drawing the graph x plus 1, meaning it will shifted 1. Okay, so here y will shift it to 1, this x will shift it to minus of 1, right? And there will be a straight line passing through it. So this will be the graph, right? Now how we are doing the this sketching. Okay, so the limit of function as x approaches 4 is the value of approaches, we get closer and closer to x equals to 4. So if the graph of fx is this is the y value which you approach, look at the graph of the fx and getting closer and closer to the point on the graph where x is equals to 4, right? So for example, if you start with the point 1 comma 2, the move the graph until we get close to the x equals to 4, then our y value get close really to the 5, right? So if we talk about the 6 7, so you only move to the closer to x equals to 4, the y value get closer to the 5, right? So the limit fx x approaches x4 is 5. This you need to remember. Okay, so this is how you do the sketching of graph. Now the next thing is, yeah, so this topic centers around the difference between a valued functions which is approaching limits and the value of function itself, right? So graphs are a great way to help visualize the difference between those concepts. Now let's look at this graph. Okay, so what you're doing, suppose the graph having some values, but it's taking this 4,4. Okay, so this limited approaching at 4,4, and then it's starting from some other places to move next, right? So what we can conclude from this graph, in the above graph we can show the difference between the value function is approaching, right? The value function is approaching and the actual value of the function. Starting on the left side of the functions and moving towards x equals to 4, we can see that the y value gets closer to y equals to 5. Okay, starting on the right side and moving backward to x equals to 4, we also get closer to y equals to 5, right? So if we try to evaluate the functions at x equals to 4, we'll get y equals to 4, right? So this is the key difference between a value function is approaching and the value function itself. So in this example, the limit is 5 and the value function of f4 is 4, right? So big takeaway for the example is that the value function at the particular value does not mean that the limit value is the same, right? Again, I'm repeating, the value function of a particular value does not mean that the limit value is the same. You can check out in the graph again. Next is estimating a limit value, which is step by step. So as you saw in the example, we estimate a limit value in a graph by approaching the x value from both the sides. So here some steps are given to estimate the limit value. So first is when to approach the x value from the left side, right side. Second is after getting a y value from the left side, approach the x value from the right side, right? Like some value is given at x is equals to 5. First you need to find the f5 minus, that will be 4.999. Then you will approach in the 5 plus, which is 5.0001, right? So this the two things you need to approach. And third is if the y value from the left side and the right side are the same, we say that the limit is that y value. And if the y values aren't equal, we say that the limit does not exist, right? So this is the given example for that. Okay, so the like how values are approaching in the graph, right? Check this example. Okay, so like 2 to 4, okay, and 2 to 5, how values are approaching. Okay, here the at 4 it's taking the value but starting again it from the 5th, right? So let's look out at example problems now. Okay, so we need to find the limit. Let me solve given question. Limit x tends to 3, x minus of 3 divided by x square minus 9. Correct. We have to find the limit at x equals to 3. Okay, so the easiest is to find the limit, plug into the x values given a function. So here you'll find that the given function isn't defined at x equals to 3, right? At x equals to 3, when you put 3 here, it becomes 9. So 9 minus 9 becomes 0. So function will be not defined, right? So the denominator values become 0 because we can't find the function value at the x equals to 3. Okay, so we will be using limit by approaching x equals to 3. Okay, so first we have to make the table. First step, making the x values to use, pick whatever the bit less than 3, meaning left to the 3, that may be like 2.9. Take values at 2.9. okay, so when you take x equals to 2.9, okay, so let me wait for a minute. Yeah, so when you take x equals to 2.9, the function's value become this 0.16949, right? At 3 it's undefined, right? Next, add a couple more x values to your table, okay, for getting closer to x equals to 3. So at 2.9 we are getting this. Now take 2.99, so you will get this. You take 2.999, you can use your calculator, you will get 0.1669, right? And at exact 3 it's undefined, correct? So now approach x equals to 3 from right side now. Okay, so till here, till this part, what we are doing, we will go approaching the left part, right? Now we move to this part. So in this, what we can do, at 3 it's exact undefined. Now let's look at 3.0001. So here you will get 0.16664. Take 3.01, you will get 0.6639. Take 3.1, you will get 0.16393, right? So our table and the function was x minus 3 divided by x square minus of 9 at x equals to 3 is 0.1116. Okay, because we have taken the estimate value from the table, correct? So now, because we are taking this value and this value and taking the immediate between, so that will be 0.16667. Okay, so it is important to pick x values that get infinitely close to the target value. So in the above example, we pick numbers that were closer and closer to x equals to 3. We were able to estimate the limit value if we use numbers with equal increment like 2.25, 2.5, 2.75. Okay, we just have to take 2.999, getting very closer to closer. Okay, so this is regarding your first example. Okay, note down this problem. Okay, so now let's look out at the properties of the limits. Okay, so what are the properties? Okay, so before looking at the properties, we'll see the theorem. Okay, so this is the theorem. Okay, so where if L, M, C and K are real numbers, okay, so if limit, when those properties gonna fall, you have to take two limits. Okay, the first limit is limit x tends to C, fx equals to L. Second is again limit x tends to C, gx is equals to M. Okay, so here first sum rule, we are talking about the sum rule. Limit x tends to C, fx plus gx will always be L plus m. Okay, second second property is difference rule, where limit extends to c fx minus gx, which is l minus m. Okay, third is constant multiple rule, where limit extends to c k into fx, then it becomes k into l. Okay, k is some constant, right? Next is product rule. Suppose limit extends to c fx into gx, so that becomes l into m. This is our product rule. Fifth is quotient rule. Limit extends to c fx divided by gx, so l divided by m, where m not equals to 0. This is the quotient rule. Okay. Next is your power rule. So in the power rule, limit extends to c fx to the power n, so it becomes l to the power n, where n is a positive integer, right? So seventh one is your root rule. So limit extends to c under root n fx, so that becomes n under root l. So we can write it as l to the power 1 by n also, where n is a positive integer. Okay, and we assume that the l is greater than 0, and when n is even. Okay, when n is even, l is always greater than 0, right? So these are the 7 properties. Okay, you can note down. Let me zoom it in. Yeah, so you can note down. Okay, so next is again one example using the sum rule to determine the limit, right? So limit is given, x tends to 3 x square plus x cube. Okay, so answer will be 36. Okay, now let's check how. In this example, we need to use sum rule. Okay, so what was the sum rule? Fx plus gx, we can write it as l plus m. So our first function is x square and our second function is x cube. First function is x square, second function is x cube. Let's take it f of x, take it g of x, right? Because the functions are being added together, we can evaluate their limit separately. So limit of x square, which approaches x3, so put 3 here, you will get 9. Now put 3 here, you will get it as 27. Okay, now this becomes your l, this becomes your l. Now you can add l plus m, you will get 36. Okay, so this was your answer. Now if I say you need to find the difference rule, so what will difference rule? That will be l minus m. So 9 minus 27, that will be minus of 18. So that will be your difference, right? So you can note down this. Next is using the constant multiple. Okay, so we are taking the same value, this. Okay, so that k into function fx, so put 5 here, so that will be 125, and the into constant is 12. So you solving, you will get 1500. The same function is given here, right? Next is using product rule. Okay, so two difference that is given. So 12 into your x to the power this, multiply by 27, 5 to the power minus of this. Okay, so while solving, you will get your answer it as 1620. Okay, and also you can check out for it that quotient rule. So that is given 12x cubed by 27x to the power minus 2. So while solving, you will get 1500 divided by 1.08, that will be 1388.889. Okay, so all these examples you can check out. These are very simple ones. Okay, now this is related to your exponent and the power rule to determine our limits. Okay, so in this example, we need to use the power rule. So we can separate out the functions 12x cubed from the exponent, right? So the limit functions x approaches 5 is 9. And now just we have to apply the exponent to the our answer. Okay, so the limit which approaches x plus 4 to the power 3. Okay, so as x approaches your 5, right? So that becomes 9 to the power cube, right? So that is 729. Okay, now you can also find out the root rule, which is essentially the same as the power rule. So the function is given that, so when root rule, this becomes under root of x plus 4, and this 3 comes here. So what you can check out 3, and when you put the 5 here, so it becomes 5 plus 4, 9, right? So solving this, you will get 2.08. So this is your answer, right? So here, let's conclude the or introductory lecture here. Okay. So now let me talk about the scoring part of the this AB calculus. Okay. So the multiple choice question section, which is your scored by your computer with the correct answer issuing 1 point. Okay, with the omitted and the incorrect answer not affecting the raw score, right? So this totally multiply by 1.2 to calculate the adjustment of the multiple choice score, right? Now let's talk about the free response, which is hand graded by the hundreds of educators each June, right? So the raw score is then added to adjust the multiple score to receive the composite score. That means total is compared to composite score scale for that year exams and converted into the AP scores of 1 to 5, right? And for the AP calculus BC exam, an AB subscore is included in the scores report to reflect their professionally in the proficiency in the fundamentals topics of the introductory calculus. So the AP score is based on the correct number of the answers for questioning to the AB materials only, right? So this you can check out. Okay, so we need to remember all this scoring part and how you need to look out at topics. Okay, so the best. This we are taking the first lecture now. Our weekly classes will be held. Okay, so you can check out the timings on the your site, which is apexams.us. Okay, so yeah, thank you. Let's wind up here. Thank you.